We need to answer the following question. It says a half-wave diode rectifier circuit is driven by a 60 Hertz sine wave, and we have a peak value of 14 volts. We know that we're dealing with a ripple voltage half wave because, well, it says so right here. So we have our half wave. We know it's ripple voltage because it's a diode. So we're going to look at the notes linked below the like button, and that's going to be on page 66. So that's where we're looking here. So we're going to use this equation to solve for it. Let's write out our values. So we know our frequency is going to be equal to a solid 60. Our VP, which is the peak value, is going to be equal to a 14 volts. If the load resistance this circuit drives is 7.1 kilo ohms, so our resistance here is going to be equal to 7.1 times 10 cubed. And we have a filter capacitor used. So our filter capacitor is going to be C is equal to 186. We have a micro, so times 10 to the negative 6th. What is the ripple voltage at the output in millivolts, peak to peak? So what we want to find here is our peak to peak. This is going to be VP. And what we're going to be using is millivolts for our units. So this is going to be 10 to the negative 3. That's what 1 millivolt is equivalent to. So let's solve for this. We know we want to find our V of R right here. So we write V of R is equal to, we have our VP, so we're going to have our 14 here. And then we have our T. Well, T we know is equal to 1 over the frequency, because T is period, and period is just 1 over frequency. So we're going to have 1 in the numerator. We can have our 60 so far in the denominator. We have our R, which is 7.1 times 10 cubed. And then we have our C, capacitance, which is just 186 times 10 to the negative 6th. And we can continue this line, the division line. We can end this parenthesis. And then we can plug this into a calculator. Now, what we can also do is take this 10 to the negative 3 and multiply it in. So once we get this, it's going to be in volts units, right? And we want it in millivolts. So to get it in millivolts, first I'm going to move this over. But to get it in millivolts, we want to multiply it by 1 milli over 10 to the negative cubed. So if we flip this over, we have to change the exponent here, and it's going to be a 10 cubed. And I put that in the calculator here as well. We can see that right here. So after I plug all that in, I'm going to get approximately 176.7. So the answer to this problem is 176.7. If you have different values, that is how we would go about solving for it.